All right. So we move on to the next chapter. It's called binabsineq. Good job. So before we go on to the next function on the list, which is rational functions, remember those? The ones with the vertical, horizontal, and slant asymptotes. We're going to stop and we're going to pick up some tools that we need. So this chapter is called binabsineq. Binabsineq, the binomial theorem, absolute values, and inequalities. And actually we're combining two chapters together. So this used to be a chapter by itself, but there's only 3 sections, and come on, we learned this in Algebra 2. And then we're also going to combine this with functions. Do you guys remember all your function operations, like how to shift graphs left, right, up, and down? How to stretch and shrink? Well, we're going to review all of that stuff again. All right, so today's homework is on binabsineq. So let's see how much you guys remember. If you have a plus b to the 0 power, what is that? Hello? Anybody home? 1. What is a plus b to the 1? Okay, that's elementary school. What is a plus b to the 2? Here, this is Algebra 1. Okay, you know what? I'm going to write it like this so you can see it better. What is a plus b cubed? When you come out of Algebra 2, you better know this one. A cubed plus 2. All I hear is mumbling. And then what about a plus b to the 4? Come on, there's a pattern here, people.
4.
A to the 4 plus. And then what about a plus b to the 5th and so forth? What do you do? Mr. Park, how do you even get these numbers? Well, you should have memorized these from Algebra 2, right? I don't know how far your teacher went last year. Did you guys do a plus b to the 4? Well, that's what. Okay, but you have to do a plus b to the 3rd, right? Okay, so where are these numbers coming from? Come on, somebody impress me. Pascal's triangle. You guys know Pascal's triangle? Who? Pascal, the French mathematician Blaise Pascal. He made a triangle like this. He started with 1, and then 1, 1. So you always have 1s on the outside, and how do you get the numbers like below these two? Really? You guys never saw this before? This is amazing. You add the 2 numbers above it. 1 plus 1 is 2. So you put 1s on the outside. 1 plus 2 is 3. 2 plus 1 is 3. And you can just extend this triangle as far as you want it. So you put 1s on the outside. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. If you somebody, huh? Where do these numbers, what do you think the application is? Look at this. Those are simply the coefficients when you expand a plus b to the nth power. You guys never seen this before? Okay, so how do I expand a plus b to the 5th? Well, what you do then is you go to the 5th row of Pascal's triangle. Yeah, but Mr. Park, no, this is the 5th. No, this is the 5th row. Okay, you put 1s on the outside, add the numbers, 1 plus 4, 5. Those are going to be the coefficients when you expand this. What do you mean this is the 5th row? That's because this top row here is called the 0th row. You know why we call it the 0th row? because it corresponds to a plus b to the 0. So this is the first row, the second, the third, fourth, fifth. So if you were to expand this, what would it be? Looking at that. Okay, I'll do the first one. A to the fifth plus, then I look over there. And I look over there. Yeah, I see a pattern, Mr. Park. Yeah, this thing is chock full of patterns. Are you guys seeing what's happening? Okay, I'll take that for a yes. I thought I was on Zoom for a minute there. Hey, so the coefficients come from Pascal's triangle, but what about the powers of A and B? How do you tell the powers? Look, the powers of A keep going down by 1, look. 5, 4, 3, 2, 1, 0. The powers of B go up by 1. Look, B to the 0, B to the 1, B to the 2, B to the 3, 4, and 5. And then look, the degree of each term is 5, right? The degree when you add the two powers. That's the pattern. Okay, so A plus B to the 6 now. What do you think I would have to do? You go to the 6th row of Pascal's triangle, and you write down the numbers. Okay, you guys do this, because I can do this in my sleep. You guys got to be able to do this when you're awake. Okay, you guys want to play the silence game? I can play it too. So you just keep looking at the coefficients. It's quite easy, you know. And it's symmetrical as well. Oh, again, that's pretty easy, Mr. Park. Okay, now, what are you guys? Class of what? Class of 22. Okay, what about A plus B to the 22 power then? Or shall we go 2022? I'll say down for the quiz. So Mr. Park, so I just got to keep making Pascal's triangle to the 22nd row then. Yeah, you can, but then what if I make it even 2022? Are you going to keep on making it to the 2022nd row? Some of you couldn't make it to the 22nd row. Some of you might not even make it to the 10th row. So is there like a better way? Like when you have higher powers? Like are these numbers special numbers? And the answer is yes. Okay, but you, unless you took SAT prep summer school, some of you were in my class. Remember combinations and permutations? Say what, girlfriend? Okay, so we're gonna have to like, where am I gonna do it? Okay, we'll do it up here. Okay, do you know the difference between a permutation and a combination? A permutation is when the order is important. A combination is when the order is not important. Okay, so we have this, the permutation of n things taken r at a time. We're not gonna do that one. We're gonna look at the combination of n things taken r at a time. Now there are different ways of writing this. Another way to write it is like this. In fact, on your calculator, I'm not sure, it might be like this, you know. But it's easy to remember. Capital P is permutation, capital C is combination. You have this button, even on a regular scientific calculator, you have this button on there. Now, how do you compute this? Well, we have a formula for that. N factorial over R factorial N minus R factorial. If you were in my summer school class, you remember that? I cannot even remember my teacher. Okay, so let's see if we can compute this. Let's get, what is, okay, so when we read this, okay, you know what, I like to use this one here. It looks more high-level mathematics that way, that's why. So, when would you use a comment? Can you think of things where order doesn't matter? Like, for example, if there's 8 candy bars on the kitchen counter, Almond Joy, Butterfinger, Crunch, Dum-Dums, Elephant Ears, Fish Food, Giraffe Food, Horse Food. Is that 8 yet? Okay, there's 8. Okay, 8 candy bars are on the kitchen counter. How many ways can you select 3 of them to put in your lunchbox? So when you're putting these into your lunchbox, does it matter what order you put it in? No, so that's a combination, the order doesn't matter. And so to compute it, you would go 8, choose 3. That's what we say, 8, choose 3. Okay, according to the formula, what is that equal to? Hello? 8, the formula's right there. 8 factorial over 3 factorial, and what is 8 minus 3? 5 factorial. Now, can I assume everybody knows what factorial is? You sure? What is 0 factorial then? 0 factorial by definition is 1, otherwise these formulas don't work. Okay, so what is 8 factorial? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What is 3 factorial? 3 times 2 times 1. What is 5 factorial? 5 times 4 times 3 times 2 times 1. Hey, Mr. Park, I can cancel. And then all you have left is this. But that's easy, look. 2, cancel, right? 6 cancel 6. What's left? 8 times 7, 56. So there's 56 different ways you could have selected the 3 candy bars. Or you could count them by hand. You could go, I can get A, B, C, A, B, D, A, B, E, and you can count it like that, but it's going to take a long time to count 56, right? So that's why this is a better way of doing it. Oh my goodness. Okay, now, do you see that when you do this, see how these numbers here cancel out? So that's like a shortcut. So when I see 8 choose 3, I don't write it all out because I know things are going to cancel out. So here's the shortcut. You see this number on the bottom? You write that number factorial, like that, 3 times 2 times 1. And then on the top, you start with this, and since you have 3 numbers on the bottom, you simply write 3 numbers on the top. See? It's this stuff here, because all the other stuff is going to cancel out. But if you want to write it, you can, it doesn't matter. And then you just go, let the canceling begin. 56. Okay, so let's practice, because you got to be good at this. Okay, how about 10 choose 4? If there were 10 candy bars on the kitchen counter, how many ways can I select 4 of them to put in my lunchbox? Or if I have 10 people, how many ways can I select 4 of them to be on a committee? 10 choose 4. Okay, so using the shortcut Mr. Park taught me what? You take this number on the bottom, factorialize it on the bottom, and then since you have 4 numbers on the bottom, start with this one, and make sure you have 4 numbers on the top, because all the other stuff is going to cancel out. And if you don't believe me, then just keep using the formula every time. Now you let the canceling begin. Goo, 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 goo. Goo, 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 goo. 210. Are you guys getting this? I don't know, man. Okay, let's do another one. How about 9 choose 6? So what would you do? Okay, why don't I just tell you what I would do? First thing I would do is I would change that to 9 choose 3. Wait a minute, Mr. Park, what? How do you know 9 choose 6 is the same as 9 choose 3? And not just because I went to preschool. Look at the formula. Okay, look, if you use the formula on this, apply that formula. 9 factorial over 6 factorial. And what is 9 minus 6? Times, I'll just write 3 factorial. How do you compute this one? 9 factorial over 3 factorial. Now what's 9 minus 3? 6. Why are these two things equal? The answer is duh. The commutative property of multiplication, A times B is equal to B times A. So, but why is it beneficial to have a smaller number here instead of a 6? Because if you're going to use the shortcut that I just taught you, I'm going to erase this. See, if you use the shortcut here, you're going to go 6, 5, 4, 3, 2, 1. And on the top, you're going to have 9, 8, 7, 6, 5, 4. Or would you rather just go 3, 2, 1 on the bottom, and 9, 8, 7 on the top. Which one is easier to work with? Again, duh. Right? So, it's better to get the smaller number on the bottom, but you don't have to. You can even use that formula every time if you wanted to. Because look, this stuff would cancel out. Anyway, once you get here, let the canceling begin. Dugga dugga 3, dugga dugga 4, 12 times 7 equals 84. See? Sometimes it rhymes. Okay, so are you guys confident you can compute these things? So what do these things have to do with Pascal's triangle, monsieur? It has everything to do. So let's look into here. This is the 6th row of Pascal's triangle. Look at these numbers. Well, it's hard for you to see, but look. This is 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. Just like in the 5th row, that would be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. All right, so what if I ask you to expand a plus b to the 22nd power? I'm going to erase all of this stuff. Too bad, because since we're videoing, we only can stay on half the board. Okay, so first of all, tell me, how many terms will there be if I expand it? Look for a pattern. A plus b to the 1 got 2 terms. A plus b to the 2 got 3 terms. A plus b to the 3rd got 4 terms. Huh. Going to have 23 terms. Now, would I ask you to write out all 23 on a quiz? No, no. Oh, so people saying yes, okay, I'm not going to disappoint you then. No, that's just monotonous. No, I'll give you this, but I'm going to say write the first 4 terms, or the last 4 terms, or something. Okay, so what's the first term going to be? Well, you would go to the 22nd row, but then come on, you can see the pattern. What are the numbers in the 22nd row of Pascal's triangle? 22 choose 0. And then what's the pattern here? A to the 22. And then the next coefficient is going to be 22 choose 1. A to the 21b. See how the powers of A are going down one by one? Remember we told you the powers of B are going up by 1? 22 choose 2. A to the 20, B to the 2, 22 choose 3, A to the 19, B to the 3, and there will be 23 of these, but like I said, I'm not going to make you do right now all 23. I'll ask you for the first 4. There you go. Now, can you compute these numbers? Because you got to simplify your answer. What do you think 22 choose 0 is? Well, according to Pascal's triangle, because there's always 1s on the outside, right? Okay, and if you don't believe me, use the formula. Look, 22 factorial, 22 factorial over 0 factorial, and then 22 minus 0 is 22. These cancel out, and that's why 0 factorial is 1. Because if 0 factorial was 0, you would get undefined here. That's why mathematicians have defined it as 1, so the formula works. Okay, so 1, a to the 22, plus 22 choose 1. I mean, according to, what do you think? Any number choose 1, what do you think it is? 22. Yeah, it's exactly, it's itself. So 22. 22 choose 2. I'm going to use the formula, Mr. Part-Time. So put 2 times 1 in the bottom, and 22 times 21 on the top, right? Let the canceling begin. Can you guys multiply 21 times 11? Without a calculator? No calculator. No. Either think of 11 as 10 plus 1, or think of the 21 as 20 plus 1. Look, distribute 210 plus 21. 231. See, you guys can do it. Okay, what about 22 choose 3? Using the shortcut Mr. Park taught me. 3, 2, 1 on the bottom, and then 22, 21, 20 on the top. Let the canceling begin. Let's see. 7, 10, So basically, you just gotta multiply 22 times 7. And the way I do it is I do like that. 140 plus 14. 154 times 10. Really? We cannot multiply by 10. We just go home, cook rice already. And there you go. Those are the first 4 terms. What if I ask you to write the last 4 terms? Could you do it? Yeah, because Pascal's triangle is symmetric. So you go in like this. Oh, I get it now. That's why 6 choose 1 and 6 choose 5 are equal. That's why 6 choose 2 is equal to 6 choose 4. See? You see that? Everything just, it just works. Okay, so that'll make, you should be able to do several problems on the homework now. But then look at the first one. So if I were to expand this, there would be 23 terms. What if I were to just ask you, find the, I'm trying to think of one, the 19th term. What would the 19th term be? So where am I going to write this? So do I just keep writing out terms and then when I get to the 19th one, box that, that's the answer? Yeah, you could, but there's a pattern here. Look, here's the first term. You have to write it out for your viewing pleasure. This is the second term. Here, I'll even point to the number you should be looking at. This is the third term. This is the fourth term. So what would the 19th term be? It would be 22 choose. Thank you. You guys see that? Because look, the third term, oh, that number is 1 smaller. Hey, fourth term, that number is 1 smaller, so 19th term, wouldn't that be 22 choose 18 then? See, there's patterns here. A to the something, B to the something. Oh, I don't know, monsieur. All I know is the 2 powers got to add up to 22. So just take a guess. No. Hey, Mr. Park, I noticed something. This number is the same as that one, look. 1 and a 1. 0, and of course, that's like B to the 0, right? 3 and 3, so if this is 18, then the power of B is also 18. But yet, the 2 powers got to add up to 22, so this one got to be 4. There you go. That's the 19th term. Now, can you simplify it? How do you compute 22 choose 18? Where on this board do I have room? Right there. How do I compute 22 choose 18? Well, isn't that the same thing as 22 choose 4? Remember when the 2, okay, remember. So using Mr. Park's shortcut, 4, 3, 2, 1 on the bottom, 22, 21, 20, 19. Let the canceling begin. Now what would I do? 4 goes into 20 5 times. 2 goes into 22 11 times. 3 goes into 21 7 times. So, what do you want to do? Multiply 77 times 95 then? Mr. Park, I don't want to do any multiplication. There's no calculator, people, anymore. And you don't have to worry because all the answers will be less than 1 million, so you don't have to worry. 90, I'm serious. It'll be less than 1 million. Okay, 5 carry 3. 5 carry 3. Oh, that's the same thing then again, right? So, 5, 1, 3, 7. Did I do that correctly? Come on, this is elementary school. So the answer would be, the 19th term would be 7, 3, 1, 5, A to the 4th, B to the 18th. Woo! Hey, Mr. Park, I really learned something today. I hope you learned something every day. So, can you guys handle this? Yeah, but we're not done yet. Just when you thought it was over. Oh no! Because Mr. Park, what is this? How you get like a fractional power or a negative number power? Because if you use Pascal's triangle only works when the power here is a whole number. Like 0, 1, 2, 3, 4, 5. What happens in the power is 2/3 or -2. what do? Go home and cry? Okay, you could do that. But if you want to go to BC Calculus next year, and you better, see, the thing is, you guys are used to just, I don't know if you guys actually learn it and then you purge it. But don't worry, in this class, see, the reason why I think you guys just perk stuff is you guys learn it and then you don't ever use it again, right? But in this class, we keep using it over and over. You know why? Because in BC Calculus, you gotta know these things. I'm training you for BC Calculus. So, Mr. Park, if I can't use Pascal's triangle or the choose thing, what do? Then what you have to do is you have to use the general binomial theorem. Say what, girlfriend? All right, so here is the so I guess if you just have to memorize one, it would be this one, because this one takes care of all of it, right? So here we go. This is called the general binomial theorem. A plus b to the n, where n can be a fraction or a negative number, but it could be a whole number too, is equal to a to the n. It's pretty much the same pattern. It just looks a little different. Plus n. The power of a goes down by 1. The power of b goes up by 1, just like in the first one, right? n minus 1 over 2 factorial. The power of a goes down by 1. The power of b goes up by 1. n minus 1. n minus 2 over 3 factorial. The power of a goes down by 1. The power of b goes up by 1. Let's just do one more for funsies. n minus 1, n minus 2, n minus 3, all over 4 factorial. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. You guys ever heard that before? Really? Can you see it's the same pattern though? Maybe you, after you use it a few times, hey, Mr. Park, it's the same thing as what we learned before. Because some of you are going, okay, here, let's do one. Okay, I don't want to do the same thing as your homework. You got 1/2. Okay, let's do, well, you got 1/2 and 1/3. No, don't have 1/3. Let's do 1/3. In fact, let's do 8 plus x to the 1/3. Now, the reason why you can't do this is because there's no such thing as 1/3 choose 0. It doesn't make sense. Or, what is 1/3 choose 2? I have 1/3 of a candy bar on the kitchen counter. How many ways can I select 2 of them to put in my lunchbox? It doesn't make sense. So that's why whenever you use this notation, both of these have to be whole numbers, and this number got to be bigger than that one, otherwise it doesn't make sense. So that's why you have to use the binomial theorem. Okay, here we go. This is A, this is B, this is N. Plug it in. In fact, this is the kind you like, right? Plug in, you don't even have to think. Okay, go. I can do this in my sleep. Can you do this when you're awake? A to the n plus n. The power of A goes down by 1. The power of B goes up by 1. n minus 1 over 2 factor. The power of A goes down by 1. The power of B goes up by 1. Okay, let's just do one more. n minus 1, n minus 2, all over 3 factorial. The power of A goes down by 1. The power of B goes up by 1. That's the binomial theorem. That's kind of easy, Mr. Park. You just plug it in, yeah? Every year. I've been teaching this 34 years. Every single year. You know what they tell me? Mr. Park, I don't understand the binomial theorem. You don't understand it, you just memorize it. It's a tool. That's what we're doing in this chapter. These are tools that are going to help you for the rest of your math career. Okay, now, this is probably the hardest part for you guys. Okay, simplify now. Woo! Good thing we didn't have to go over homework, otherwise we'd be in big trouble. Okay, I'll do the first one. 2. Okay, who's got the second one? I don't even know your names yet. I'll just guess. Liu? Liu? Here, I got it. Simplify. Just simplify the numbers then. Okay, remember, negative exponent means 1 over, yeah?
1 over 12.
Okay, very good. Everybody can do that? Everybody knows 8. Okay, do we have to review algebra 1 and algebra 2? 8 to the negative 2/3 means 1 over 8 to the 2/3, right? Come on, this is SAT stuff, right? And then how do you compute 8 to the 2/3? Are you in the school of going 8 squared and then cube rooted? Or would you rather cube rooted and then square it? Which one is preferable? Yeah, you cube root it first because it makes the number smaller. Cube root of 8, 2 squared, 4, so you get a 1/4 times 1/3, that's how you get the 1/12. Okay, we're only on the second term, Mark. Okay, who's got the next one? I'm gonna see if I can recall any names here. Graham. Yeah, I got it. Okay. I'll give you the minus sign and the x squared. You just got to figure out this number. Let's see if we can do it in our head. Woo. Okay, you can write on, you don't have to do it in your head. I'm just trying to do it in my head. Okay, I got it. It's going to be 1 over something. I forgot what I just did in my head. Okay, I got to do it again. Okay, got it. No calculator now. You cannot use calculator. The answers are less than 1 million, so you don't have to worry. Okay, I'll give you a hint. 2 factorial is 2. This 2 cancels that 2. And then this is like 1 over, okay, let's try to do that in our head. Do the cube root first. What is the cube root of 8? 2. What is 2 to the 5th? 32. So basically, you got 1/9 times 1 over 32. So basically, you just got to multiply 32 times 9. That's the hard part, Mr. Park. Or whatever your name is. Okay, Grant, what do we got? 32 times 9. Here. Just do this if you have to. Just do it the old-fashioned way. Okay, there, I did it already. You guys are going to have to do this. I can do this when I'm sleeping. You gotta, like I said, you got to do it when you're awake. Okay, oh my God. Mr. Park, what am I going to do here? Well, if I were me, can I cancel this 3 with one of these 3's? Because every year students, no, you can't. Because when you divide by a fraction, that's like multiplying by the reciprocal. So this 3 is actually in the bottom. So maybe you want to write 3 times 2 times 1. Don't have to write the 1, but this 2 cancels that 2. And then what about this? That's 1 over, what is the cube root of 8 again? And what is 2 to the 8? That's the problem this year. Rhymes with 288. Oh my goodness. Okay, so what do you got on the top? You got a 5. And then, what is 3 times 3 times 3 times 3? 81. So you got to multiply 256 times 81. Mr. Park, please, no. If you're lucky, I won't go that far. Maybe I'll just make you do 3 terms. What is it tonight? It says 4 terms. Okay, come on. Oh, my dog can do this. 8 carry 4 carry 4. 6, 3, 7, 0, 2. So I got 5 over 20,736 x cubed. Did I do that correctly? I hope I did. Okay, now, like on tonight's homework, now I'm going to say, using your result, estimate Okay, this is the last thing. Estimate the cube root of 9. Using this result, estimate what the cube root of 9 is. I don't even know what's going on, Mr. Ford. Look, here's the original problem. Isn't 1/3 power cube root? Okay, what number do I have to plug in for x to get 9? 1, see? 8 plus 1 is 9. 9 to the 1/3 is cube root of 9. So all you have to do, and I'm not going to make an ugly number. It's going to be a really nice number. What happens when I plug in 1 for x? You get? What would be a good approximation? 2 plus 112 minus 1 over 288 plus 5 over 20,736. Oh, I get it now, Mr. Park. The more terms you use, the closer you're going to get to the actual value. That's right. Oh, so that's why it goes on forever, because this is an irrational number, right? So the more terms you add up, the closer you get to the actual cube root of 9. So, you know what? Like, you know, I'm not, if I actually gave you this on a quiz, I wouldn't make you go to that 4th term. I think that would be too. So here, just use 3 terms then. Can you guys simplify that? Can you imagine making the least common denominator with that? That would be crazy, yeah? Come on, we're almost done. What is the least common denominator for these 3 numbers? I'll give you a hint. This is 2 over 1. I'll give you another hint. 12 goes into 288. Okay, thank you. Okay, so what goes in the top? I'll do the first one. 576, is that right? Yep. Okay, plus, and I'll even do the last one, minus 1. I'll give you a hint. 12 times 12 is 144, which is half of that. Okay, see, you guys got it. So this simplifies to, what's 576 plus 24? That's 5, no, that's 600. 600 minus 1? 599 over 288. This would be a pretty good approximation for the cube root of 9. And of course, if you add this term in, it's even a better approximation. The more and more terms you use, the better your approximation is. And then I'm going to ask you, what is the percent error? How do you compute percent error? Everybody here took chemistry, right? You guys have to do lab experiments, or even in biology. So how do you compute percent error? Experimental minus the actual over actual times 100. Okay, now I'll let you use your calculator. Do I have to take, wait, I don't think my phone can even do 2 meters. Where's my calculator? No, I only can do addition, subtraction, multiplication, and division. Give me 3 decimal place accuracy now. Come on, you guys got it. You guys have the app on your whatever you call these things, iPads. Also, Mr. Park, we're going to have to do some pretty heavy-duty computations this chapter, yeah? Don't worry, you guys practice, but if you don't practice, you're not going to get good. Of course, on a quiz, I'm not going to let you use a calculator, so you just leave your answer like this. Okay? Because I know you guys can. Okay, somebody got an answer. What do we got?
Negative 0.0107.
0.01. Huh?
07.
Like that?
Yeah.
Percent?
Yeah.
So that means you're below the actual answer. That actually makes sense. Actually, it doesn't make sense. I think we should be above the answer. Are you sure it's negative? Everybody got negative. Oh, so we're actually below the actual answer. Perhaps it is, but I don't know, it just doesn't make sense to me. Unless we computed something wrong here. I don't think so. Anyway, all we did is add 3 numbers and you're within 0.01% of the actual answer. That's pretty darn good, yeah? That's why this stuff is golden. That's why we study it. And then you know this thing about adding up numbers? This is a whole chapter in calculus. We call this a series. So yeah, see, if you're going, you guys know the difference between AB and BC calculus? No, okay, so I guess one of the biggest reasons why you're in this class is because you want to get to BC calculus, right? But to get to BC calculus, you need an 80% of, well, if you look in the manual, it says B minus in this class, but actually, it's actually 80%. 79.9% doesn't cut it, okay? Although, if it's written down, I guess we have to take it, but you need okay, let's just go with that. You need a B minus or better in this class for your final grade. Okay, and then, so BC, what is the difference between BC and AP? Well, it's kind of like honors, no, regular and honors, although this is an AP class. You get 5.0 for each class. It doesn't matter. Except this one, you only get 1 semester of college credit. This one, you will get 2 semesters of college credit. So if you can get to BC, you should take it. Because like last year, I mean, usually, maybe of all the people that take BC calculus, maybe 1 person might get a 4 on the AP exam. Everybody else gets 5. Because that makes sense, right? Because this is the creme de la creme of math students at ELMI school, right? Yeah. But even if you don't make it, you got AB. That's 1 semester. Save money, right? Anyway, I don't know if you know this, but as you go through the honors program at ELMI, what happens is it just gets wider apart. So like the difference in Algebra 1, regular and honors is like that, then geometry, Algebra 2, pre-calculus, and then by the time you get to calculus, it's just super wide apart, the difference. So this course goes really, really fast. Covers way more material than this one. So you gotta, that's what this class is for, to train you for that. Okay, anyway, again, I'm glad we got that on video. So you should be able to do, well, yeah, I gave you a hint on number 7, so you guys should be able to do that. All right, we are done then. This class ends when?
105, or 205.
Okay, well, why don't we just go home already? Let's go home to Christ, unless you got another class. Were you guys able to hear me better with this? Yeah. Okay, see you later. Okay, bye. See you later. Okay, look. Oh, yeah. Bye. 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 Okay, see you later.